As the demand for power continues to rise, so do the challenges in converting electrical voltages and currents to match the source with the demand.
More than $1 trillion worth of electricity is produced in the United States in a year. And electricity is one of those products which is consumed literally the second it's produced. And there's a wide variability in the consumption of electricity, which means your production has to adjust on a second-by-second basis of how it's being consumed. Now that's a very difficult challenge. No other industry does face such challenges, and it is going to be critically enabled by how you can process power in order to match the production with the consumption of power.
You could actually reduce the cost of the photovoltaic farm or wind energy down to a very cost-effective manner, but you still have to deal with the transmission of getting that power out to where the load centers are.
For most power systems, including existing electric utility grid systems and those used with solar and wind farms and electric ships, electrical energy originates in one form, say DC, and must be converted and output in another form, often AC. Power switches perform that function. Present state-of-the-art conversion systems are inefficient, in part due to expensive cooling requirements. Also, to better utilize renewable energy sources, such as wind and solar, new technologies are needed to store, process, and then transmit this power when needed through the existing grid, microgrids, or the next generation smart grid. Researchers at GeneSiC Semiconductor and Sandia National Laboratories now have a commercially available family of Thyristor switching products made from silicon carbide that can help systems operate more efficiently, enhancing the quality, availability, and reliability of power.
So the heart of these power conversion systems for energy storage applications or photovoltaic applications, or even fault current limiters or circuit breakers that electric utility utilizes, the heart of that system is semiconductor switch. It's all in the materials. There's a lot of materials research to make this particular switch work with high temperature capability, high voltage capability, high current applications.
Thyristor technology has been around for some time, but the GeneSiC Sandia Labs silicon carbide-based thyristors offer 10 times higher voltage, 100 times faster switching frequencies, and much higher temperature operation compared with conventional silicon-based thyristors.
Now, silicon carbide offers great advantages, but it's also got many significant technical challenges of how to make transistors out of this material. And that had to be figured out for the first time. We did a lot of experimentation, almost 2 years of experimentation of what would be the right designs that would work in silicon carbide, what would be the right fabrication steps. I have to say, just to make the chip from the raw silicon carbide material, there are over 250 steps, unique steps that you have to go through. It actually takes us months to finish them. So there's a chip mounted inside of this package, and it sits right on top of this base plate, as we call it. The chip is mounted pretty much in the center of it, and there is a terminal that is electrical terminal that is connected to the base plate here, and another terminal that is connected to the top terminal here. This is called the anode and the cathode, and these are gate signals. In semiconductor world, when you are developing a new semiconductor technology, a single experiment could take you $100,000 to $140,000 and may take up to 4, 5, 6 months. And the probability of success of an experiment could be less than 10%. So we are very appreciative of the funding that we received from Department of Energy, and later on now we have funding from the Army, and one of our customers is actually using it for a Navy application and yet another one for an Air Force application.
Starting as a small business innovation research project with DOE's Office of Electricity, and then partnering with Sandia Labs and others, GeneSiC has provided unique design, fabrication, packaging, and testing of these thyristors. In addition to the electric utility grid, other applications include current and next-generation electric ships, weapons systems, and pulsed power.
It was an unbelievable moment when people started expressing interest in us to buy these devices from us. It was a great moment. It's an active, very actively evolving product for us. It's already at a very good commercial state, but we believe we will be able to offer a family of such products which may number in tens of different ratings, different characteristics, that will usher in new innovations for both military and commercial use.